Okay, so lesson 69, more gas law problems. We've already done some gas law problems, and these are just like those, except that now we are using a lot of scientific notation in there. So the basic equation, ideal gas law equation, one of them anyway, is P1 V sub 1 over T sub 1 is equal to P sub 2 V sub 2 over T sub 2, where P, V, and T represent the pressure, volume, and temperature of an ideal gas. And we have initial pressure, volume, and temperature, and then we have the final pressure, volume, and temperature. Quantity of ideal gas had initial pressure, volume, and temperature values of 40 times 10 to the fourth atmospheres, that's pressure, 0.0003 times 10 to the negative 6 cubic centimeters, that's volume, and 700 times 10 to the fourth kelvins, that's temperature. Find the final temperature if the final pressure was 0.0004 times 10 to the 15th atmosphere, and the final volume was 0.015 times 10 to the negative 14th cubic centimeters. So we're going to start by solving for the final temperature because that's what we're looking for. Find the final temperature. And since we are going to have to plug in all this messy stuff, it's best if we just go ahead and get T sub 2 by itself before we even start. So we'll cross multiply. Since this is a proportion, we know the cross products are equal. So P sub 1, V sub 1, T sub 2 is equal to T sub 1, P sub 2, V sub 2. And if I want to get T sub 2 by itself, I just need to divide both sides by P sub 1, V sub 1. So that's going to give me T sub 2 is equal to T sub 1, P sub 2, V sub 2 over T sub 1, V sub 1. And now I just need to plug in the values that they gave me. 0.0004 times 10 to the 15th, that is here. And that is the final pressure. So that's the P2, P sub 2 right there. And then 0.015 times 10 to the negative 14. That is here. That's my final volume. So V sub 2. And then 700 times 10 to the fourth. That's the original temperature. So that goes right there. And then on the bottom, I've got 40 times 10 to the fourth, which is right here. That's the original initial pressure. So that's P sub 1. And then 0.0003 times 10 to the negative 6 is the initial volume. So V sub 1. So I got everything filled in, and now I just need to simplify it. Scientific notation, that is the correct form. You want only one digit to the left of the decimal place, so you would write it as 3.5 times 10 to the 6th kelvins for the final temperature. So now you've got a quantity of ideal gas, which had initial values of 0.003 times 10 to the 14th pounds per square inch, that's pressure, 0.007 cubic centimeters, that's volume, and 7,000 kelvins, that's temperature. Find P sub 2 if the final volume was 3 times 10 squared and the final temperature was 0.003 times 10 to the 7. So same exact kind of thing. You've got P1, P sub 1, V sub 1 over T sub 1 is equal to P sub 2, V sub 2 over T sub 2. And you are looking for find P sub 2. So we need to solve for P sub 2. So we will cross multiply, and we'll have P sub 1, V sub 1, T sub 2 is equal to T sub 1, P sub 2, V sub 2. And to get P sub 2 by itself, we need to divide both sides by T sub 1, V sub 2. And if we do that, we're going to have P sub 2 is equal to P sub 1, V sub 1, T sub 2 over T sub 1, V sub 2. So now we just need to plug in the values and figure out what we have. So the initial pressure, P sub 1, is 0.003 times 10 to the 14th. The initial volume is 0.007 cubic centimeters. The initial temperature, which goes on the bottom, was 7,000 kelvins. The final temperature was 0.003 times 10 to the 7th, and the final volume, which is V sub 2, was 3 times 10 squared. So if we simplify this, we've got 0.003, that's 3 times 10 to the negative 3, so up there we have 3 times 10 to the 11th, and then we've got 7 times 10 to the negative 3, and then 3 times 10 to the negative 3 times 10 to the 7th, so that's 3 times 10 to the 4th. And then on the bottom, we have 7 times 10 cubed times 3 times 10 squared. So we can cancel some things. We have a 3 on the bottom and a 3 on the top, and a 7 on the bottom and a 7 on the top. And then we have 3 on the top. We have 3 times 10 to the 11 minus 3 is 8, plus 4 is 12. And then on the bottom, we have 10 to the 5th. So this is going to be 3.0 times 10 to the 7th, and it's going to be pounds per square inch. Okay, here we have some more of these abstract equations where we have all kinds of letters, and we want to solve for one of the letters and get it completely by itself. So on this problem, solve for b, x equals p times 1 over a plus m over b. The first thing you're going to have to do, because you're going to solve for b, you're going to have to get all into that set of parentheses there and somehow extract that b. So the first thing you're going to do is use the distributive property and just multiply that p by everything in that set of parentheses. So x is equal to p over a plus pm over b. So we've got that common denominator of a, b. So what we're going to do is we're just going to multiply the whole equation by AB, and that will cancel all the fractions. That'll make all the fractions go away. So AB times X is ABX, and then when we multiply AB times P over A, the A will cancel and we'll have PB. And we multiply AB by PM over B, the B will cancel and we'll just end up with AMP. We're going to put all the terms that have a B in them on one side and everything else on the other side. So we're going to subtract PB on both sides. ABX minus PB is equal to AMP, because we want our answer to have B on one side and everything else on the other side, and we don't want any B's to be on the right side. We just want it to be B equals something, and that something better not have any B's in it. All right, so the thing we have to do, we got everything with a B in it on the left side of the equation, everything else on the right side, and now we just factor out the B on the left side. So we'll have B times AX minus P, and now we can get B completely by itself. All we have to do is divide both sides by AX minus P, and we're good to go. So you can see that B is by itself, and there are no B's on the right side. They have to be all gone, and there has to just be B equals. That's what it means when it says to solve for B. Okay, here's another example. You have to use the distributive property before you do anything else. So we're going to distribute that M to all the things in the parentheses. So we'll have XP is equal to MB over 1 plus C plus AM over P. And now we need to multiply the whole equation through by the common denominator. And the common denominator is P times 1 plus C. So multiplying everything by P times 1 plus C. That's going to make all of the fractions go away because all of those denominators are going to cancel. So when we multiply P times 1 plus C times XP, we're going to end up with P squared X times 1 plus C. And on the right side, when we multiply P times 1 plus C by the first term, the 1 plus C is going to cancel and we'll be left with PMB. And then when we multiply P times 1 plus C times AM over P, the P is going to cancel and we'll just end up with AM times 1 plus C. Now we have to use that distributive property once again because we have to isolate the C's, and there's no way to do that until we get all that stuff multiplied out. So on the left, we're going to have P squared X times 1, which is P squared X, plus P squared X times C, which is C P squared X. On the right side, we've got our BMP, and then we have to distribute that AM. AM times 1 is AM times C is AMC. So now we did all our distributive property. And what we have to do now is, since we're trying to solve for C, we have to get every single thing that has a C in it on one side of the equation and everything else on the other side. So I'm going to subtract AMC on both sides to get the C's all on the left. And then I'm going to subtract P squared X so that everything else is on the right. So I'm going to have minus AMC on the left plus CP squared X moving the p squared x to the right, I'm going to have bmp plus am minus p squared x. So got all my c's on the left side, and now I just need to factor the c out. So c times p squared x minus am is what I have on the left, and the right is just exactly what I already said before. So nothing has changed over there. And now to get c completely by itself, we'll divide both sides by p squared x minus am. And so c will be all by itself, bmp plus am minus p squared x, all over that denominator that we divided both sides by, p squared x minus am. So now we have c on the left. We don't have any c's on the right, isolated, which means that it has been solved for.